For generations, Betelgeuse has stood out in the night sky as one of the most recognizable stars in Orion. Its enormous red appearance has fascinated astronomers for centuries. But behind that familiar glow is a massive star approaching the final stages of its life. Eventually, Betelgeuse is expected to end its life in a spectacular supernova. Exactly when that will happen remains uncertain, because stellar evolution unfolds on timescales far beyond a human lifetime. Then, in late 2019, something happened that suddenly made that distant future feel much closer. Betelgeuse began losing brightness. The change was dramatic. The star became far dimmer than astronomers were accustomed to seeing, creating immediate excitement among observers around the world. For a moment, the question was impossible to ignore. Was Betelgeuse finally preparing to explode? The answer turned out to be no. Observations suggested that a huge amount of material had been expelled from the star. As that material cooled, dust formed within it, temporarily blocking part of the light reaching Earth. In other words, the star had effectively hidden some of its own light. The event became known as the Great Dimming. The immediate mystery appeared to have an explanation, but astronomers still had another problem. Betelgeuse had been behaving strangely for much longer than the 2019 event. The star naturally changes in brightness over time. One major cycle occurs over roughly a year, as the enormous star expands and contracts. But researchers had also noticed another, much longer pattern. That second variation was harder to explain. For years, scientists considered possibilities such as turbulent activity on the stellar surface, enormous convection cells, and changes in the star's outer atmosphere. Then researchers began examining something different. Instead of focusing only on how bright Betelgeuse appeared, they studied how the star was moving. Historical observations, including old astronomical records, offered a remarkable opportunity. By comparing measurements collected across many decades, scientists could search for tiny changes in the star's motion. And eventually, a pattern emerged. Betelgeuse appeared to move back and forth in a regular cycle. That kind of motion can have an important meaning. A star can wobble because another object is orbiting it. When two objects orbit a shared center of mass, their movements can reveal the presence of a companion even when that companion cannot be directly seen. Suddenly, the strange brightness cycle began to look different. What if the variations were not caused entirely by changes inside Betelgeuse? What if another star was influencing it? The possibility of a hidden companion had actually been considered before. But detecting such an object would be extremely difficult. Betelgeuse is enormous and extraordinarily bright. Its outer atmosphere is filled with turbulent material and giant convection structures. Any smaller companion nearby would have to compete against the overwhelming glare of the red supergiant. It would be like trying to identify a tiny lamp next to an enormous searchlight. So astronomers turned to orbital calculations. If a companion existed, its position would change as it traveled around Betelgeuse. There would be certain periods when the companion moved farther from the star's brightest region, creating a better opportunity for observation. This gave researchers something extremely valuable: a prediction. Instead of simply searching randomly, they could calculate when and where the suspected companion should appear. And when powerful observing equipment was eventually aimed toward Betelgeuse during a favorable period, astronomers found something remarkable. A faint point of light appeared extremely close to the giant star. Its position was consistent with the predicted orbit. The discovery transformed the mystery surrounding Betelgeuse. The star might not be acting alone after all. For more than a century, a companion could have remained hidden in the glare of one of the brightest and most dramatic stars in Orion. But the story was only beginning. Because if this companion really is gravitationally connected to Betelgeuse, Their relationship could tell us something extraordinary about how massive stars change, and how they eventually die. The possible companion of Betelgeuse changes the way astronomers can look at the famous red supergiant. Instead of seeing a single dying star, scientists may be looking at a system containing two stars whose futures are connected. The smaller companion is believed, according to the source scenario, to be much less massive than Betelgeuse and still relatively young. That creates a remarkable contrast. One star is approaching the later stages of its evolution, while the other may still have a huge portion of its stellar life ahead of it. Yet both objects are locked into the same gravitational dance. As the companion travels around Betelgeuse, its repeated approaches could disturb the outer layers of the enormous red supergiant. That interaction could help explain some of the unusual changes astronomers have observed. Instead of random behavior, certain variations in brightness may reflect a repeating orbital rhythm. The companion could influence material around Betelgeuse, contribute to changes in its atmosphere, and affect how gas is released into surrounding space. This possibility is especially interesting because massive stars lose enormous amounts of material during their later stages. Their outer layers become unstable. Powerful outflows carry gas away. Dust can form. And the star gradually changes as it approaches the end of its evolution. If a companion is repeatedly interacting with those outer layers, the process could become even more complicated. But there is an even bigger question. What happens when Betelgeuse eventually reaches the final stage of its life? The source scenario suggests that gravitational interactions could slowly alter the companion's orbit over very long periods. If the smaller star gradually moves closer, the two objects could eventually experience an increasingly violent interaction. A merger is one possible long-term outcome. Such an event would be extraordinary. A massive red supergiant and a smaller companion combining into one system could release enormous amounts of energy and redistribute material around the star. It could also change the conditions surrounding the eventual stellar explosion. But this is where an important distinction must be made. A future merger is a theoretical possibility within the scenario, not something that can be treated as an imminent event. Betelgeuse's supernova itself is also not expected on a precise human timetable. Astronomers know that the star is nearing the end of its evolutionary journey, but predicting the exact moment of its final explosion is extremely difficult. That uncertainty is part of what makes Betelgeuse so fascinating. For years, its changing brightness seemed to be a collection of unrelated mysteries. The Great Dimming appeared to be one event. Its regular pulsations were another. The longer brightness cycle seemed like something else entirely. But the possibility of a companion provides a new way to connect some of these observations. A star that once looked isolated may actually be part of a much more complicated system. And that realization could have implications beyond Betelgeuse itself. Massive stars are often found in binary or multiple star systems. Their companions can influence how they evolve, how quickly they lose mass, and what happens when they eventually die. If hidden companions are more common than previously recognized, astronomers may need to reconsider some models of massive star evolution. That is why the possible companion is important. It is not simply another object near a famous star. It could provide a new explanation for behavior that has puzzled astronomers for decades. And Betelgeuse reminds us of something profound about astronomy. The night sky can look peaceful while enormous events unfold across it. A star can appear as nothing more than a tiny red point of light, yet behind that point may be a gigantic system involving gravity, stellar winds, changing atmospheres, and an uncertain future. We see only the light that reaches Earth. The real story is happening far beyond our planet. Betelgeuse has already shown astronomers that familiar stars can hide unexpected secrets. And as technology improves, observations may reveal even more about its companion, its atmosphere, and its eventual fate. The next major surprise may already be traveling toward us as light. We simply have to keep watching. Because sometimes, the most extraordinary discoveries are hiding beside the